Good morning. Today let us see a topic under linear convolution. Convolution is nothing but analysis of unknown signal x of n and h of n. H of n is the response of impulse signal. Okay, so analyzing the unknown signal x of n and h of n to get another signal y of n, we call it as convolution. Actually, under convolution we have various types. One is linear convolution, circular convolution, overlap and add method, overlap and save method. In linear convolution, when we see x of n and h of n, it will be almost equal number of elements, or one or two elements greater or smaller. But in circular convolution, both your x of n and h of n will be of equal elements. And whenever your x of n and h of n length is much larger in difference, we will go for overlap and add method and overlap and save method. Now let us see linear convolution method. Now we are considering three different types of input signal, where in the first problem the origin is not mentioned. In the second problem the same numbers, but in the second problem we can see the origin is mentioned in the x of n, but it is not mentioned in h of n. The third type of sum is origin is mentioned in x of n and h of n, and it is not the first element which is the origin. If the arrow mark is not given, it means that first element is the origin, and if the arrow mark is given, whichever element it is pointing, that will be the origin, which means here in this problem n is equal to 0. At n is equal to 0 you have the element 2, and so at n is equal to minus 1 you have the element 1, and this is at n is equal to 1 you have the element 3, and n is equal to 2 you have the element 4. So this is the meaning. So whichever place the arrow mark is pointed, that indicates the origin position. Now to solve this linear convolution method, we have four different methods for solving. One is common multiplication method, second one is matrix multiplication method, the third is graphical method, and the fourth one is formula method. Actually, this common multiplication method is useful only to solve a problem where the first element is the origin. Here, out of this three sum, only the first element is the origin for both x of n and h of n. In this case alone, this common multiplication method will give you the exact result. If the origin is shifted to second element, say in case of the second and third problem, this common multiplication method will not give the correct answer. So we have to go for the second method called matrix multiplication. Matrix multiplication gives a better answer in case of the second type of problem, where the origin is shifted in one x of n, but the origin of h of n is the first element. See, this is the matrix multiplication. Now we are doing it for the second type of problem, where the origin is shifted to the second element of x of n, but h of n is having the first element as the origin. In this matrix multiplication, x of n and h of n is plotted. X of n value is written as 1, 2, 3, 4, and h of n value is 1, 3, 1. So let us do a normal matrix multiplication, and when we are writing down the answer, we have to choose an element in such a way that first it will be a single element, then a double element, then the 3 element. After that it should decrease. It is 3 element, no? So next one is 3 element, 2 element, and 1 element. So like this we have to carefully draw the diagonals. If you are making mistakes in drawing the diagonals, then we will not arrive at the correct answer. Now just write the first one as 1. The second one is sum of this 3 plus 2 is 5. The third element is 1 plus 6 plus 3, it is 10. The fourth element is 2 plus 9 plus 4, it is 15. The fifth element is 3 plus 12, which is 15. The last element is 4. Right? So since we are going to consider this second type of sum, where x of n origin is shifted to the second element, here y of n also the origin will be shifted to the second element. So we have to put the arrow mark in the second element. So this matrix multiplication will give you the better answer. Okay, so the same matrix multiplication method, the other type is your graphical method. That is, we have seen here the three methods of solving is common multiplication, matrix multiplication, graphical method, formula method. Now for the same second problem, let us solve using the graphical method. In graphical method, the first step is we have to draw graphically your x of n and h of n. Your x of n is the element you can see here. It is origin is 2, minus 1, n is equal to minus 1, you have the element 1. So I have drawn n is equal to minus 1, the element is 1. At origin 0, see here 0, I have plotted the value as 2. Then at position n is equal to 1, we are having the value 3, n is equal to 2, we are having the value 4. So 3 and 4. Similarly, I have plotted for h of n, that is origin, it is 1, n is equal to 0, it is 1, n is equal to 1, you have 3 element, and n is equal to 2, you are having 1. Okay, now this h of n has to be folded. So we will fold h of n to get your h of minus n. So when we are folding this, imagine this to be a mirror. You retain the element of n is equal to 0 as 1 same way, but whatever is there on the right hand side will be folded like this to the other side. So if you see here, this 3 will go to this minus 1, this 1 will go to n is equal to minus 2 position. Hence you will get like this. Okay, at 0 you are having the same element 1, at n is equal to minus 1 you have the element 3, n is equal to minus 2 you are having the element 1. So you imagine your y-axis to be the mirror, and whatever is the right hand side element, it is being shifted to the left hand side. Okay, after your folding, the third step is you need to multiply your x of n and h of minus n. So I have drawn once again your h of n, and I have redrawn your h of minus n. So we need to multiply these both to get the answer for y of 0. So when we are multiplying these both, at n is equal to minus 1, the element is 1. Here n is equal to minus 1, the element is 3. You need to multiply 1 and 3 to get 1 into 3 is 3 here. And similarly, you check your origin position. X of n origin, you have the value as 2. H of minus n origin, you have the element 1. So multiply this 2 and 1 to get 2 into 1s are 2. Okay, all other elements on the right hand side, it cannot be multiplied with the right hand side element of h of minus n, because all the right hand side elements are 0. So 0 multiplied with any of this right hand side element is 0. So you will not get any value in this side. Now coming to y of 0, you are having 2 amplitude as 3 and 2. Add these both, 3 plus 2, to get your answer as 5. So your y of 0 is 5. How will you arrive this y of 0 value is just fold your h of minus n and multiply with x of n. Okay, now the next step is you are going to shift your h of minus n one step to the right to get n of minus n plus 1. Okay, so here is your h of minus n. So it is the origin starts at minus 2, minus 1, 0. Shift one step to the right hand side, then minus 2 location will go to minus 1 location, and minus 1 location value will go to 0 location, and 0 location the element will go to 1 location. This is shifting this h of minus n one step towards the right hand side. Right hand side means the positive x axis side. Okay. Now after shifting, multiply this value, this is your h of minus n plus 1. Okay, multiply this value with your x of n, which is the quotient. Okay, here you have origin minus 1, 0, 1 and 2. I have similar to here, this is your x of n, the same thing is written here. Okay, now you are going to multiply your x of n and h of minus n plus 1. Okay, when we multiply these both, what answer you get will be y of 1. Now at each and every location you multiply the amplitude. N is equal to minus 1 you have the amplitude 1. N is equal to minus 1 here you have the amplitude 1. So 1 into 1 is 1. You mark it in location minus 1. Now go for origin 0. Okay, you have the element 2. You have the element 3. 2 into 3 is 3 2s are 6. So you mark it in the origin 0. Now coming to n is equal to 1. At n is equal to 1, you have 3. Here n is equal to 1, you have 1. So 3 into 1 is 3. You mark it in the n is equal to 1 as 3. So now you have 3 elements, 1 plus 6 plus 3. Add these 3, you will get at an answer called 10, which is nothing but y of 1. So this is how you are going to get your y of 1, y of 2, 3, 4, etc. Now how are you going to get your y of minus 1 answer? Y of minus 1 answer. Here h of minus n is here. That you are going to shift one step towards the left to get this one. Minus 3, minus 2, minus 1. It is shifted once. This value is shifted one step to left hand side. So minus 2 and it goes to minus 3. So this is how you got. So this is nothing but h of minus n minus 1. Now the next step will be you will multiply x of n. It is not convolution. It is a mere multiplication. You are going to multiply x of n value with h of minus n minus 1 to get your y of minus 1 values. So here I have drawn your x of n. Here I am going to multiply it. Yes, it is just multiplication, not convolution, with your h of minus n minus 1 value. Similar to the previous step, you will multiply each location wise and you are getting the answer at minus 1, you are getting the output as 1. So this is your y of minus 1 is equal to 1 answer. If you keep repeating, you will get an answer similar to your matrix multiplication. That is, n is equal to 0, you got y of 0 as 5. At n is equal to 1, you got y of 1 value as 10. At n is equal to minus 1, you got answer as 1. So if you are going to repeat in this step, you will get the remaining answers. And you can always cross check your graphical method with your matrix multiplication method to understand whether your graphical method sum whatever you have solved is correct or not. Thank you.